Okay, welcome back to the continuation of lesson 0.2, second video. I'm going to try to keep these under 15 minutes so that it's easier for you to break them down into chunks and watch them at different times. Where were we? We were at the next line in the Hello World program, system.out.println, hello Franklin APCSA, close parentheses, and then this guy at the end, this is a semicolon. So this line here, this is called a statement. And a statement is just a single instruction for the computer to perform. Almost always, you're going to have a semicolon at the end of a line with this, of a statement. And the semicolon basically just says that this is like a period. You know, if you're writing an English sentence, then at the end of every sentence, you're going to write some, period or exclamation mark or some punctuation. Semicolons are used in Java programs to denote the end of this statement. Statements are executed in order when the program is run. So that's pretty important to note. That the order that you write those statements in your main matters, and it's going to run them sequentially, so from top down. And as I said earlier, statements typically end with the semicolon. Okay. All right, so let's take a look at this example program. Public class hello Franklin, public static void main, string bracket args, etc., etc. And then we have these three: system.out.println. Note that L is an L, and it's pronounced println, L-I-N-N. Let me write that down, actually. So this is L-I-N-N, println. And we have three of these println statements. One of them says hello class, this is a basic program, doesn't do too much yet. So let's go ahead and answer a couple of these questions. So first and foremost, what is the name of the class? So you can pause it for a second or just think about it. Answer to this question is hello Franklin, right? Up here at the top, hello Franklin, capital H, capital F, that's the name of our class, and it's camel-cased. What must the name of the .java file be? Take a second. If you want to pause it, you can. Write the answer down. The .java file must be hellofranklin.java. Remember that the case and spelling, everything, must be identical to the class. So our file is going to be called hellofranklin.java because the class is hellofranklin. Okay, another question. How many statements are there? This one's pretty simple. There are three statements, right? System.out.println, system.out.println, system.out.println. So we've got three of these. What do you think the output of the program is, given that it runs sequentially? That's the output. So it's going to say hello class, exclamation mark, and then on a new line it's going to say this is a basic program, period. And then it's going to, on a new line, it's going to say it doesn't do too much yet. So that's our output. So this is what the program produces. 3 lines, one for each of these statements. Pretty simple. Okay, so in general, what a Java program will look like is this. So you've got your class, public class at the very top. Your program's name will follow that. So whatever the program is called, with an open squiggly brace here. And then you'll have your main method. You can either put the main. Now the order these methods are written in does not matter in Java. Some other languages it does matter. But in Java it does not. We can put the main at the top. We can put the main at the bottom. But we'll have some main method. and we'll have a sequence of statements, as many as we want, and then we may have additional methods besides main. And we'll talk about how we can write our own methods later this week in another lesson. Again, methods are pretty important for structuring code. They help us avoid redundancy, writing the same code again and again, and also help us organize everything so that it's in nice units that make sense. Okay, so we might have multiple methods besides main, and they'll all be at the same kind of level of indentation as main. So the indentation is like this. In this case, the class header is not indented at all. Same with the class closing squiggly brace. So these are not indented. The main method header is indented 1 because it's inside the class. So everything inside the class needs to be indented 1 level. Everything inside main is going to be indented again to denote that it's inside of main. So all of the statements that are inside main will be 1 level of indenting. 1 more. So that's 2 levels, I guess, because it's inside the class and then it's inside the main. And if we have further open squiggly braces, it's easy to remember this. Whenever we have this open squiggly brace, the stuff that's inside that goes in between the closing squiggly brace and the open squiggly brace are going to be indented 1 more level so that it's easy to see that it's inside those squiggly braces. So that's going to be important when we get to some other pieces of code that you can use. They're called control structures. Code that controls how your code is flowing. Those use curly braces, and we want to make sure we indent properly with those. So it's good to get practice now. Okay, so as I said, there can be as many methods and statements as you would like, some finite number. I don't know what the biggest Java program is. You could have probably a very large .java file with lots and lots in it. We've never hit that in this class. We'll talk more about how you can write and use your own methods, which are these guys over here, in a later lecture. So don't worry too much about that, just this is how it's structured. So let's talk about the distinction between compiling and running our program. These are kind of 2 different steps. And in Java is what's called a compiled language. You've got to take your program that you wrote and actually break it down into another language, which is called Java bytecode, before you can run it. And this step of taking the Java you write and turning it into this other language is called compiling. So anytime you want to run or execute a program, execute, run, those are going to be interchangeable. You have to compile it you have to compile all the .java files that program needs. So you might have more than one .java file, which when we get to more complicated programs, we'll have several .java files. So this is an intermediate step, and it's going to convert that Java code that you wrote, the public class, public static void main, system.out.println, all of those things get converted into what's called Java bytecode. Now Java bytecode is pretty unintelligible. You can't read it as a human. Maybe some people can, but it just looks like gibberish. But the computer can understand this and execute instructions based off of the bytecode in the .class file. So this gets created and gets dumped into the out folder when we build a program in IntelliJ. And that's called, so it's called building in IntelliJ as opposed to compiling, but that's what it's doing, is compiling all the .java files. So we can take a look at that. So when we write this, when we do build project here, it says all files are up to date, but if I change something like this, then it's going to rebuild it and compile it. It says compilation completed successfully since there were no errors. And then this hello world.class file gets generated in the out folder. Now you don't actually ever need to open this .class file, and as I said before, it's going to look like gibberish if you were to open it up. We're writing everything in the .java files, but this needs to get created in order for the program to be run. Okay, so when we want the computer to actually run the program, we must already compile it. We must have already compiled it. So the Java bytecode is what actually gets run by the computer when we run our program. So that running step, that's going to be up here, run hello world, select run. If you haven't run this program yet already, there's our output, hello Franklin APCSA. If you haven't run it already, you'll go down to this run, Alt-Shift F10, and it's, this run, and then select the main method that you want to run, and we want to run the main method from our hello world.java class. So we'll click on this one, and it's going to run hello world, the main method from hello world. Okay, so there we go. You can also click these little green arrows too. If you click this little green arrow, it's going to run the program for you as well. Okay. So a little bit of a note about compiling versus scripting. We're not going to get too detailed into these, but not all languages are compiled. It's just important to be aware of this. Languages that don't have you compile the code into some other language first. When you compile, you're always going to create some other file. You're going to create something else, which is a lower level language than the one you're writing in. So C, C++, Java, all of these are examples of compiled languages that when you write your code in C or Java, it then gets converted into something that humans generally can't understand, and or is a lot harder to read, a lot harder to understand, that the computer can run. Okay. Scripting languages don't have this compilation step. They're not going to generate additional files. They just are going to get read line by line, and if something is broken in the program, it's just going to break once it hits that line in it. We'll talk more about what that means when we get into different kinds of errors you might see when you're writing Java code. So some examples of scripting languages I've written here are Python, JavaScript, Bash. If you've done any web programming, then you've probably used JavaScript. Python is another really common language for all sorts of things. It's pretty simple to get up and running, and it's used a lot in math and science, and it's pretty popular scripting language out there. And then Bash, that's a command line language for Linux or Unix operating systems, not Windows operating systems. But you can write programs that are Bash scripts, and they're going to run. It's another scripting kind of language. It's a little bit of a different flavor from the other two. Okay, so what are the benefits to a compiled language? Why would we ever want it to actually run this additional step? So the compiler gives us some more feedback as to where and what the errors are. So having this step where it's going to read through our code line by line and make sure everything is correct before we actually run before we can run it is really useful so that we can find and fix errors. So the compiler is actually your friend, not your enemy. Even though the red squiggly lines are going to be annoying and irritating initially, that's good. Errors are very important for learning. So it's going to run faster than a scripting language, almost always. because you're not having to interpret the language on the fly. This English or Python or whatever language you wrote, you're not interpreting it on the fly and then the computer's executing the instructions. You're taking the instructions, breaking it down into this language that the computer can understand more easily, and then running it. So that step of breaking it down is done for you once you compile it, so it's going to run a bit faster than a language that's scripted. And the other upshot to it is generally when you have compiled languages, it's easier to organize things. You can build more complex programs and maintain order and organization in them than scripting languages. Now, scripting programs, you generally are going to be writing quickly to accomplish a simple task. Maybe you want to just scrape the web for something, or you want to organize files in a folder, etc., etc. That's what scripting languages are good for. When you're trying to build a complex program, you generally want a compiled language for that. So a lot of code out there is written in C, C++, Java, because you want to do something complex with it. So, all right, if you're curious, you can read more about it at that website right there. What's the difference between scripting and programming languages? Or you just Google it and spend a little bit of time reading about it. Okay, so that's the end of the lesson 0.2, where we talked about the basics of what is a Java program, and what's Java versus some other scripting languages, what's compiling, what's running. Hopefully that was a useful lesson for you.